In practice exam question 3, we're looking at a problem where we've got a plywood company is working on improving practices to reduce problems when it runs the logs through the lathes. And here it says improper conditioning of the logs is thought to be the primary cause of the problem, and conditioning is affected by two factors: water temp and the duration the logs are heated. Okay, so here we've got a two-factor Anova test, or that's what's coming up here, because there's two things that we're looking at, isolating and seeing how they affect the conditioning of the logs. Alright, so it says the mill has tested 3 temperatures and 3 durations. Alpha is 0.01. And we've got some results we'll look at here in a second, but as we do, or as I move over to this part of the problem here, where we're going to fill in this table, I'll just point out a couple of things here, is that we've got, as we know, we've got two factors, and we'll have columns and rows here, or sample it says, and columns. And here we've got a total of 26, and we know that this total degrees of freedom is the total sample size minus 1. So what this would look like here, I'll just move over a little bit more. If we imagine the table being laid out for testing in Excel, we would have 3 temperatures, and those are our columns, so we'll say A, B, and C, and this is temp. And then here we have the hours of the duration. We've got D, E, and F. And to get to 27, right, each combination has been tested 3 times. Like this. So this is what the spreadsheet might look like if you were going to set up this test and run it using the Excel tools to do that. But you see here, then we would have 9, 9, and 9 total, and that would be 27, and that's the connection there. So this is just to set your expectations of what it is we're looking at, or what the data setup might be. So we get the hours and temperature, and we're going to test this to see how they affect the conditioning of the logs, or if they can be said to affect it. And then we'll also have to look at whether there's any interaction between the two or not. Alright, so what we have to do first is fill in this table here. Again, this is very similar to the Excel output, only we've got some gaps in there, so we have to fill that in. And just as a reminder, like all the other tests we have, these columns will need to add up. Here, our sum of squares total will be a sum of these various factors here, factor A, B, the interaction, and the error, or the sum of squares within. This is also referred to as. And then there's different ways to calculate degrees of freedom depending on what we're doing. For the factors, it's the factor minus 1, so here and here. And then for the AB, the interaction, it's degrees of freedom for A times degrees of freedom for B. And then the error then is the total minus A times B. For our mean of squares, we just divide each by the other. So mean of squares for A is sum of squares for A over degrees of freedom for A to get this, and so on down the list there. And then here, then we get 3 F statistics. The denominator in each is always mean square of errors, or mean of squares within. So this number right here is always going to be your denominator. And we have 3 F statistics that we're looking at. The first one that we'll look at eventually to test is, was there any interaction between A and B? That is, you would expect them, if there were no interaction, for the results to be largely the same, the way that they interact. If there's interaction between them, then there's some combination there that's throwing things out of whack, and you would need to reconduct the test. And then here, then the other 2 tests, assuming we find that there's no interaction, we would then look at these tests and say, can one be said to be different than the other, to help isolate this conditioning problem of the logs. So one might be, does the duration that the logs are heated have any effect, or do the the temperature at which they're heated. Does that have any effect? And so that's what we're trying to isolate here with these two factors. All right, so back to the questions at hand here. And let's make this a little bit larger. All right. So here, this one is all filled out across the top here. We've got our sum of squares for the hours. Degrees of freedom is 2. You recall there were 3 different durations we tested for, so 3 minus 1 is 2. The mean of squares is just going to be this number here divided by 2. And then the F statistic is this number divided by this number. And then we come up with this. And then we've got the critical values already filled in. All right, so we'll get to that in a minute. So the sum of squares for columns is our first question we're looking at, A. And to do that, remember, all of these have to add up. So 7.48 is going to be the sum of all of these 4 values here. So to find out with a missing one, we just subtract these values, here, here, and here, from 7.48. And when we do that, we get 1.22. Okay, so that is the first part. 1.22 is the answer for A. The degrees of freedom for columns, and that's our water temperature. So if you remember the table that I drew a minute ago, there were 3 columns. So 3 minus 1 is also going to be 2. And then to get the, so this is 2. And degrees of freedom for interaction is going to be degrees of freedom for hours times degrees of freedom for water temp, here and here. And 2 times 2 is 4. So as if by magic now, if we add up 2 and 2 and 4 and 18, we should get 26. So that's the way we can check our work there. So we've got 4 right here. And then the mean of squares for columns is part D. And in part D, we're going to divide 1.22 by 2. So that's this row right here. So 1.22 divided by 2 is 0.61. Okay, so 0.61. And then the mean of squares for interaction, we're just going to repeat that same type of a procedure here. We're going to divide 2.28444 by 4. And we get 0.571. 0.571. 0.571. And now we have what we need to do the next part, which is the calculated F statistic for columns. So if you remember, this value is going to be the denominator in all cases. So the first part here on F, we're going to say the calculated F statistic for columns. So we're going to divide 0.61 by 0.203704, and for that we get a result of 2.99. 2.99. And then we'll do the same thing for the last question on this part, which is what is the calculated F statistic for interaction? And we divide this 0.571 here by 0.203704, and we get 2.80. 2.80. So we've answered all of these, and now we can kind of get an idea of where we're going here on the next set of questions, where we're going to interpret our table here. And so we've got our critical values are given right here. Right? So if we imagine our decision rules, we would be saying if the value is greater than these critical values, if our calculated F here is greater than these values, then we will reject the null. And across the board here, it looks like we are less than, in all cases, less than our calculated value. So that's sort of a preview of our next set of questions. Let's take a look at those now. And let me zoom out a little bit. All right, and come back in. All right. So first we're going to test whether there's an interaction effect. Okay, so our null and alternative hypotheses are given to us here, here, and here. It says water temperature and hours of heating do not affect the mean temperature, or excuse me, the mean output, and the alternative is that they do. Okay, and so that's the first set of hypotheses, and says, based on your calculations and the table above, you conclude that there is no interaction, or is no, that's the question, interaction between factors. So we go back up here again, and we're going to look at the interaction row here. And here our critical value, so if our calculated F statistic is greater than 4.579, we will reject the null and say that there is interaction here. We see 2.8 is less than that, so we will say there is no interaction between them. If I can find the pencil, I will circle that. Is no interaction. All right, so that is our first test. So we passed that first hurdle. There's no interaction, so okay, our tests are valid. Then we can look then to see whether factor A or factor B, or factor the water temperature is the first one we'll look at here, if that has any effect, or if any one temperature is statistically significant in its results. So we're looking at these as our null and alternative hypotheses. The null is that all the temperatures are equal. The mean value of each is equal, and the alternative is that not all populations have the same mean. Okay, so we'll zoom back up here and look at this. So we're looking at water temperature now. So that is this second row. And here, if we can see through all of the circles here, this was 2.99 was our calculated value. That is less than our critical value of 6.01. And so we will say in that case, because our calculated value is less than the critical value, we will say, based on the calculations above, we conclude that there is no difference between the means for the water temperature. That is, we did not reject the null, and we're saying that all the mu's are equal of each of the water temperatures. Okay? And now we do the same thing for the second test, which is of the heating duration. Here we're saying all of the heating durations are, the mean output is the same, and in the alternative that not all of the heating durations will have the same mean. Okay, so again, we're looking at the same thing here to see, is there any result that would be statistically significant here to say that one duration over another produces a different outcome. And here, the last circle here I'll draw, again, this 0.758 is less than 0.6012905. So our calculated value is less than our critical value, and therefore we would say we will not reject the null and conclude that there are no differences in the heating duration. That is, we're saying, based on our test results, we found that the null held, that the mean was the same, or it was not statistically significant, the difference between them, and therefore we cannot reject the null. So that concludes the questions on the test here, but the mill would then have to go back and look at what else, it's kind of back to the drawing board for them, what else might be causing the variation in their output. These particular factors, the water temperatures and the durations they tested at, did not result in any findings for them to act on.